All right, so we went over this kind of quickly in class, and I also was asking you guys to try to apply some of the things that we've learned in the past when we're multiplying coefficients with variables and treat it like it's the same when we're doing with radicals. But you guys seem to really struggle with this, so I said I was going to make a video going over these questions that we did. So this way, if you need to watch it, you can. All right, but we are multiplying and dividing radicals right now. Right, we are multiplying and dividing radicals. Remember, there is one very important rule that you have to look for every single time. And if you're going to multiply or divide radicals, our indices has to be the same. If they are the same, then we just simply multiply any of the numbers on the inside. So if we're multiplying the square root of a times the square root of b, it's simply just the square root of a times b. The index does not change. It still remains the exact same. And then if there's any numbers on the outside, we will just multiply those as well. And we'll go through that in the examples. And when we're dividing, same thing. We look at our index. Are they the same? Yes. Then we simply just rewrite it underneath the same fraction. So it's just a divided by b. And the same thing as before. We do not change our index. It just remains the exact same. All right? And one of the things, though, with division, we will have to do it for multiplication soon, but with division, you do have to make sure that you can go into one radical, and then you'll also have to be able to separate it as well. So since those are the same index, we can just go ahead and rewrite them as their own separate fractions if we'd like. All right, so you must, for division, be able to go both ways. Rewrite it if they have the same index, rewrite it underneath of the same radical, and then there's going to be times where if I give you the problem where it starts off under the same radical where we rewrite it separately. And you'll see that in some of the examples that we're going to do. All right, but the key thing, the main thing you have to look for every time is, are the indices the same? Because if they're not, then there's nothing you can do. And if there is, then we simply are just multiplying or dividing numbers. All right, so let me go through these 9 problems real quick. All right, the first one is simply just the square root of 2 squared. So we know that whenever we're raising something to the second power, it's saying we're multiplying this by itself 2 times. So we can do the square root of 2 times the square root of 2. Then we look and see, are the indices the same? Well, this is a square root and this is a square root. So yes, they are. And since they're the same, I can go ahead and write them underneath the same radical and simply multiply the numbers on the inside, or our radicands, and 2 times 2 is equal to 4. So now I have the square root of 4. And then you ask yourselves, well, can we actually take the square root of 4? Yes. The square root of 4 we know is equal to 2. That is our final answer. I went through in class, if our index matches our power, if our index, which is here, matches our power, that they will undo each other. Or you can simply expand them out and multiply. It is completely up to you. Either one is acceptable. All right, let's move on to the next question. All right, I tried to show you one way of doing this in class. We haven't learned how to simplify yet. That's the next section. So since we haven't learned that, I'm only going to tell you to do this for right now. We have raised to the third power, so that means we need to multiply this by itself 3 times. So the square root of 2 times the square root of 2 times the square root of 2. Well, since all of our indices are the same, they're all square root, that means we can just go ahead and rewrite this underneath of one radical. So I can rewrite them all 2 times 2 times 2. And we know 2 times 2 times 2 is equal to 8. So for right now, you can leave it as a square root of 8. This can be simplified. We simplify radicals just like we would simplify the fraction 4 over 8 would simplify to 1/2. We need to simplify all of our radicals as well. But since we haven't learned it yet, and you guys seem to be confused with the way I was doing it in class, this is how you just need to do it for right now. Right? And then after the next section, you will need to simplify this. All right, but that is it. You just simply look to see if our indices are the same, and then we multiply whatever is inside of our radical, or called our radicand, and we multiply them together. It's really simple. All right, you guys are making it way harder than what it needed to be. All right, let's go to the next question. All right, we learned before that if we have something in parentheses and is being raised at second power, well, everything gets distributed to that, or the power gets distributed to everything. So that means it's going to become 4 squared over the square root of 2 squared. Well, I'm not going to go through this step. We already did this. Right? We did this in question 1. So you should know that the square root of 2 squared is equal to 2. If you're not sure, you can either rewind and go back to question 1, or you can expand it and multiply it. And then I know 4 squared is equal to 16. right? But we never leave our answers as 16 over 2. Right? We must simplify. 16 divided by 2 is equal to 8. Right? You guys were forgetting the rules that we just learned in our last chapter. You weren't applying this square to both. You were just sitting there and saying, this is too hard. I can't do this. But this is something that you are all definitely capable of doing. Right? You were just trying to look for an easy way out of trying to not do any work. Right? But you are applying any of the rules or all the rules that we were just going over, that you just got tested on. All right, let's move on to the next question. I'll start numbering them now because I realize I haven't been numbering them. This one was question 3. The exact same thing that we were just talking about. All right, but maybe you don't know what this means. When the 3 is written really big, remember I told you that if it's written really big, I said that in class, it's not our index. Our index, if we want it to be the cubed root of 2, we would have to write it small. So you know it's your index. When it's written large like this, it's saying 3 times. So we're actually multiplying this. 3 times the square root of 2. Well, just as we just talked about in the last problem, if there's something in parentheses being raised to the power, everything gets that power. So it becomes 3 squared times the square root of 2 squared. And as we've already gone through in question 1, and I just said it again the last one, the square root of 2 squared we know is equal to 2. And 3 squared is 9. Well, what is 9 times 2? 18. All right, so make sure when it's in parentheses, everything is getting that power. Right? Do not forget any of the rules that we just went through. All right, so now this one's presented a little bit different. We have 3 times the square root of 3 times negative 2 times the square root of 3. Well, if I gave you 3x times negative 2x, you all know how to do this. We would multiply our likes with our likes, so our coefficient, so it'll give us negative 6, and x times x gives us x squared. Nothing changes when we're multiplying radicals. There's this one huge difference. We first need to look at the index and say, are they the same? Because if they're not, then there's nothing we do. But they both are. They're both the square root. So that means we will multiply our likes with our likes. So we'll multiply the numbers on the outside. So 3 times negative 2 is equal to negative 6. And then our radicals, we simply just rewrite it under the same radical, 3 times 3. Well, I know 3 times 3 is equal to 9, so it's the square root of 9. All right, now, do we know the square root of 9? Yes, the square root of 9 is equal to 3, so instead of square root of 9, I will write 3. And now we have 3 times this, negative 6 because this is being multiplied, and it's negative 18. All right, the operations don't change. We were once multiplying these two numbers here. This is being multiplied, so it's always going to be multiplied. Right? For some reason, when you guys see minus signs, you start thinking that we're subtracting, and you will do 3 minus 2. Remember, parentheses mean multiplication, so we're multiplying everything. And then after we finish, because this is being multiplied here, and after we can take the square root of 9, we still need to multiply these two numbers. They give us negative 18. Right? This one's easier than the ones that we're just doing. We're just simply multiplying two radicals, so we look and see, are the indices the same? Yes, they're both square root. So when they're the same, it's nice and easy to simply just multiply the numbers on the inside. Well, what is 2 times 10? 20. So it's the square root of 20. Right now, this in the future will be able to be simplified, and it won't be acceptable as your final answer. But for now, we haven't learned it. So this is simply just the square root of 20. That's it. Right? You guys are really making this a lot harder than what it needed to be in class. All right, but if you don't know and you're not sure, watch this video. Well, you should be watching it now, so if you're watching it, it's because you don't know. But then reach out and remind if you still need help. All right, here we have 3 times the square root of 2. Remember, when it's written large like this, it's being multiplied. Parentheses mean times, so it's times 4 times the square root of 11. So first we look and see, before we can do anything, are the indices the same? Square root, yes. So now that means I multiply my likes with my likes. So I'm going to do 3 times 4. Well, 3 times 4 I know is equal to 12. Right? Then I'm going to multiply my other likes. That's my radicals. So square root of 2 times the square root of 11, we simply just multiply the numbers on the inside. So it is 2 times 11 or 22. Right? When you're writing this, though, you do not write the multiplication symbol like I did here. So you simply just write the number large next to it, and it lets the reader know that this is being multiplied. So it's 12 times the square root of 22. All right, so we multiply our likes with our likes, just as if it was 3x times 4x. You all know how to do this. So if you know how to do this, then you can do this problem here as well. All right, now we're dividing. The square root of 75 divided by the square root of 3. Same rule every time. I had you guys shout it in class. All right, we look at our index. Are the indices the same? Yes. If our indices are the same, we can rewrite this under one fraction. And the reason why I am is because when I look at the square root of 75, I know it's not a whole number. It's not going to be 8. It's not going to be 9. It's going to be 8 point something. So that tells me, since it's not a whole number, that it's going to be difficult for me to do this because we can't use a calculator. And the square root of 3 is not a whole number either. It's between 1 and 2. So I know it's going to be some decimal, an irrational number. So what we do is we then look and see, well, can I combine these under one radical? And since they're the same index, we can. And then we see, can I reduce them? Well, 75 divided by 3, you all should know, is equal to 25. So instead of writing 75 and 3, I can then write the square root of 25. And now, do you know this? You should all know that the square root of 25 is equal to 5. Because remember, when we say the square root, we're saying what number times itself twice gives me 25. And you can use that sheet that I gave you to help you solve this as well. All right, we're moving on to the last question, and that'll be it for this video. All right, now the last question, I know I made you guys put them together, the fraction, the dividing, because it made it easier for us because we could simplify, and when we simplified, it gave us a perfect square. So it's like, awesome, we can just do this, and it makes it a lot easier for us since we can't use a calculator. Well, sometimes the problem will start out as a fraction. And if it starts out like this, you look and see, can I reduce 9 and 49? But no, we can't. There's no common factors. So then we look and see, well, can I take the square root of 9? Or can I take the square root of 49? Or can I simplify these? After we learn how to simplify, you'll also have to ask yourself, can one of them be simplified? So yes, I know the square root of 9 and I know the square root of 49. So instead of having them under one fraction, instead of having them under one radical, I can separate them. And then I look and see, well, what is the square root of 9? 3. Because 3 squared is equal to 9. What's the square root of 49? 7. Right? What number times itself twice gives us 49 and 7? So now a problem that first looked like we couldn't do it, when we separated them and looked at the numerator on its own and the denominator on its own, it was something that we could actually take the square roots of, and it was something that we actually could do. All right, so that is it for this video, going over all those 9 questions. It's not mandatory. You'll be able to skip around. But if you have any questions, just reach out and remind.